time to keep expanding on solving equations. But instead of having just one step in our equations, we're going to add a couple extra steps to it. But the same principles apply here. We want to get the variable by itself in the end. So always do the inverse of what's being done, and whatever you do to one side of the equal sign, do to the other side of the equal sign. So let's take a look at a few examples here. Looking at number 1. Okay, find your variable. Well, my variable is n on the left side. Okay, right here. Well, I got to think. I'm multiplying by 2, and I'm also adding 11 to that n. Well, before I can deal with this 2, it's kind of connected to that n, isn't it? So I got to get rid of everything else before I do the stuff that's connected to the variable. So I'm going to start with that plus 11. Well, the inverse of adding 11 is subtracting 11. Whatever I do to one side of the equal sign, I do to the other. So we go ahead and subtract. Bring down everything that you don't use. So I bring down my 2n. Doing the inverse gets rid of it. Bring down my equal sign. 3 minus 11, or 3 plus negative 11 is negative 8. And then same thing. Look at my n. What am I doing to it? Multiplying by 2. The inverse is divide by 2. Whatever I do to one side, do to the other. The 2's cancel, so I bring down my n. Equals negative 8 divided by 2 is negative 4. And we're done. Okay, so just follow through that process in your mind, and you'll be fine. Looking at number 2. Okay, here's my variable a. I got really a negative 2 multiplied by that a, and then out front is a positive 6. It's really a plus 6 out there, isn't it? So I got to think, deal with that 6 first. Well, what's the inverse of a positive 6, or adding by 6? Well, it's subtracting by 6. A lot of people think this is a minus 6. Well, it's not. The minus goes with this 2. It's a negative 2 times a. Okay, you always look at the sign that's in front. The sign that's in front of this 6 is a plus. It's a positive 6. So the inverse of a positive 6 is a negative 6. And whatever I do to one side of the equal sign, I do to the other. So this 6, negative 6 cancel. Bring down. Don't forget to bring down your minus sign here. So negative 2a equals negative 2, right? 4 minus 6. And now same thing. Here's my a. Multiplying by negative 2, the inverse is divide by negative 2. Whatever I do to one side, I do to the other. My negative 2's cancel. I'm left with a equals positive 1, right? Number divided by itself, and negative divided by negative is positive, so a equals 1. And just like always, I could plug this back in if I wanted to and check my answer. I could plug it in and take 6 minus 2 times 1 equals 4, and if I notice 6 minus 2 does equal 4, so I'm good. It checks out. And lastly, number 3. Okay, this gets a little trickier. If I notice, my variable is in the numerator. It's up top, and it's got a plus 9 with it. So usually you subtract 9, right, from both sides. Well, what do I have below that? I have a divided by 12 to that whole thing. This guy is blocking me from subtracting 9 right away, so I got to get rid of that guy so I can get that k out of that fraction. So in order to get rid of this 12 down here, I got to think, this k plus 9, I'm dividing by 12, aren't I? Well, the inverse of dividing by 12 is to multiply by 12. So I'm going to multiply by 12, because that's really, 12 over 1, and my 12's cross cancel, so I'm left with k plus 9. That's how that works. So I'm going to do the inverse of what's being done here. So dividing by 12, which means I multiply by 12. Whatever I do to one side, I do to the other. My 12's cancel. I'm left with k plus 9 equals negative 24. And now I can subtract that 9, right? The inverse of adding 9 is subtracting 9. Whatever I do to one side, I do to the other. So k, these are gone, equals negative 24 and negative 9 give me negative 33. And we're done. Okay, so just do the inverse of what's being done. Whatever you do to one side, do to the other. Make sure you got to get rid of that fraction if that's the case. In a story problem, the biggest thing is just getting an equation set up and assigning a variable to the thing that you don't know. So for example, Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half off, half its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? So this is what I don't know, the original price of the coat. Well, if I think about it, the original cost, I'm just going to call that cost, okay? What happened was you had half off, so you subtracted half of that cost, didn't you? And then you took another $10 off because of that coupon, and you finished with a total price of $125. Well, let's assign a variable for cost now. Let's just call cost C. So I could say C minus 1/2 of C, right? 1/2 times C. That gives me half of a number. Minus 10 equals 125. Well, before I do the inverse of what's being done, I need to simplify my C's here. I have 1 whole C minus half a C, which leaves me with half a C, right? 1 minus a half leaves you with half. So combine that. Minus 10 equals 125. And now I can do the inverse of what's being done. So we add 10 to both sides, right? The inverse is subtracting 10. And we're left with half of C equals 135. And remember, it's C times 1/2. Well, the inverse is dividing by 1/2, which is the same thing as multiplying by the reciprocal. So we're going to multiply by 2 over 1, or really just 2, right? So C equals 270. So make sure, I'm going to bring my answer up here because I need to put a label on it since it's a story problem. So the original cost was $270. Okay, it's all about setting up that equation with a variable to solve. That's the biggest part of this. And then just going through your steps. Lastly, consecutive integers. Whenever you see consecutive integers, that means integers counting in order. So if it says consecutive integers, that's like if I started with 5, so 5, 6, 7, 8. If it says consecutive even integers, well, now you're talking just evens. If it said odds, then you're talking just odds. And I say this because we get problems like this that say find 3 consecutive odd integers with a sum of 57. So I got 3 consecutive odd integers with a sum of 57. So sum tells me I'm adding, correct? So I'm adding 3 integers that are going to add up to 57, and they're all odd. Well, I got to think about this. I can't just call the first one n for any number. Because if I just say n, n could be an even or an odd. So what could I do to that n to make sure it's an odd? Well, let's come down here. Let's look at that n. Well, if I just added a 1 to it, it still doesn't help me because 2 plus 1 is an odd, which is good, but 3 plus 1 is an even. So that doesn't really help me. What happens if I would multiply? What if I multiplied by 2, for example? Doesn't that guarantee it's an even? Anything times 2 is an even number. Well, if I know that's an even for sure, if I would simply add 1 to an even, doesn't that make it an odd? Right? Because any even number plus 1 makes it an odd. So if I plug in 3 for n, I would get 2 times 3, which is 6, plus 1, which is 7. So 2n plus 1 works for any odd number. 2n plus 1. So if that's my first odd number, let's just call it 13. Let's say 13 was my first odd number. My next one would be 15, right? So how do I get to 15? I just add 2, don't I? So that's how I get my next term. So this is my first odd number. It was 2n plus 1. And now I'm saying I'm adding 2 to that, right? I'm adding 2 to that to get to my next odd number. Well, 1 plus 2 gives me 3. So let's just simplify that right away. And my next one, I'd add another 2 to that. So 2n plus, well, 2n plus 3 plus 2, which gives me 2n plus 5. Right, because I'd go to 17. This is just an example. This is not the answer. Okay, so let me get rid of this. So that's how you come up with that. So the 2n plus 1, this is my odd number. I got to add 2 to that odd number to get to the next odd number. So that's where that plus 3 comes in because I added 2 onto that first one. Then I got to add another 2 onto that to get to my next odd number. So now we just simplify and we can solve. So I have a 2n plus a 2n plus a 2n, which gives me 6 total n's, 6n. And then I have a 1 plus 3 plus 5 for plus 9. I'm just combining like terms. And now I can go through and solve. So do the inverse of what's being done. The inverse of adding 9 is subtracting 9. Whatever I do to one side of the equal sign, I do to the other. So the 9's are gone here. So I bring my 6n down, bring my equal sign down, and we have 48, 57 minus 9. And now divide by 6, right? The inverse of multiplying by 6 is dividing by 6. 6 is cancel, n equals 8. Well, I'm not done. Go back and reread. Always reread your directions. I can't stress that enough. Reread directions. It says find 3 consecutive odd integers. Well, this 8 stands for n. So I'm going to plug this into my first expression I came up with because that's my first odd integer, right? So I'm taking 2 times 8 plus 1, which gives me 17. So there's my first odd integer, 17. So I'm going to write this in blue here. So 17 is my first one. Well, I can just figure out my next two. 19 is my next odd integer. 21's my last because they're consecutive odd integers. And if I would add them up, they would add up to 57, right? 19 plus 21 is 40. 40 plus 17 is 57. Okay, so it's about setting up that equation. Come up with an expression for that first number and then base the others off of that. And then the sum tells me to add up. So it takes a little bit of thinking there. All right, that's all I got. Good luck with your solving.